This is the Virginia Education Center for Asphalt Technology. My name is Todd Mansell, and we will be covering paving best practices. With that, the role of the paver is to meet our specifications for grade, texture, and smoothness. So what is grade and slope? When we talk about grade in this presentation, we're really talking about thickness of the pavement. When we talk about slope, we're talking about percent crossfall or percent slope in the roadway. Mat texture. So paving operations, the goal really is to have a uniform mat texture from one edge of the pavement all the way to the other. So if everything is set up properly on the paver, we're operating things correctly, using our best practices, that mat texture should look the same from one end gate to the other, all the way across the width of the mat. To do all this, we need good base. And in this slide, as you can see, this is a picture of poor base conditions before we pave. So I just thought I would throw that in there. We'll talk about paving operations best practices, but again, to do that, all the best practices, we have to have good base to start with. So understanding the paver. There's really two major components to the paver. There's the tractor and the screed. So the tractor is what tows the screed. The tractor, or commonly just called the paver in general, accepts mix from the trucks or from the MTV, from the material transfer vehicle, and it feeds the mix back to the screed. The screed is what finishes off our mat. So the screed is what we call a free-floating screed, floats on the mix, so the asphalt mix underneath that screed is all that's actually supporting or holding that screed up while we pave. And it's free to rise and fall according to several different factors that we'll talk about here. So looking at the tractor, the big thing here, again, it pulls or tows the screed, but it really is the material feed system. So we've got the hopper that receives the mix from the trucks or from the MTV. We've got slack conveyors with feeder bars on them that convey the mix from the hopper back to the augers. And we've got adjustable height augers back in front of the screed that we can raise or lower. And then feed sensors back at the screed that control the rate of flow of the mix from the conveyors to the augers and across the face of the screed. The next thing, again, is the screed. So today, mostly what we see in the industry are what we call hydraulic extendable screeds. So the screed is extendable to pave different widths. It'll have a fixed base width. Generally for highway or major roadways, they're either an 8-foot screed or a 10-foot wide main screed with hydraulic extensions that can extend in and out to various paving widths. Fixed width screed, sometimes those are used not as much nowadays as they were in the past, but basically what a fixed width screed is, instead of it's hydraulic extendable, but on the outside or the outer edges of that screed, you'll have bolt-on extensions. So they're fixed or rigid extensions, they come in different width sections, 1 foot, 2 foot, that can be bolted on. Once a fixed width screed is set up, you can't vary that width while you're paving. So it's set up, it's fixed width. They tend to be a little more rigid, but you're not able to vary the width as you're paving. There's two different types of screeds you'll hear about. There's front mount screeds and rear mount, so that's the terminology. What it really refers to are the extenders on the screed. So you have hydraulic extensions that go in and out on the right side and the left side. If it's a front mount screed, those extenders are in front of the main screed. On a rear mount screed, those extenders are behind the main screed. On a front mount screed, again, the extender, as you can see in the picture on the left side there, you can kind of see the guy's foot there on the catwalk behind the main screed. The extender with the hydraulic bars on it is in front of that main screed. So that's a front mount screed. On the right side picture, if you look down into that screed area, again, you'll see a very kind of narrow area on that front extender where the mix sits and the augers are. On a rear mount screed, on the left side picture, you can see the extenders are behind the main screed. And on the right hand picture, looking down, you can see a lot more mix in the extender on a rear mount screed. So that's one of the big differences between front and rear mount screeds. A rear mount, you're carrying a lot more mix, if you will, while you're paving along on the rear mount, but they also tend to be generally, because they're carrying more mix, a little more forgiving in terms of variability in the feed system. So if your mix runs a little high or a little low, rear mount screed's a little more forgiving in that regard. So the screed's free floating. Again, screed position is going to determine your mat thickness. So where that screed is, again, it's just floating on the mix. So the position is going to stay constant, or your thickness will stay constant, as long as all those forces or factors acting on that screed remain constant. The free-floating screed principle has not changed since 1934, when Barbara Green first commercialized the free-floating screed. So even though we have technology today, we see machines and equipment with a lot of electronics, grade controls, all those things on there, the principle of how the free-floating screed works has not changed in 80 plus years. So what are the factors affecting the screed? If you look at this schematic here showing the screed, and then the tow arm in yellow goes up to the tractor where it's connected at a pinned connection. The factors affecting the screed are paving speed, head of material, which we'll explain in a little bit. That's the amount of mix in front of the face of the screed. Screed adjustments that we can make. The mix design will have an effect on how that screed floats. Mix temperature, so the hotter the mix is, the easier, more it flows underneath the screed. Air temperature and base temperature that we're paving on to a lesser degree also affect how that screed's going to float. Angle of attack of that screed is very important. That's the relationship between the nose of the screed and the grade. So if you look at this picture here, to pave properly and have that mix flow nicely underneath that screed and leave a nice smooth mat, that screed has to have what we call a slight nose-up attitude. It's typically about 1/4 of an inch or 6 millimeter angle of attack. When we make screed adjustments and we want to change mat thickness, that screed rotates through an arc while it's changing thickness. And that's the only purpose of really showing this slide right now, is to show that when that screed changes mat thickness, it's actually traveling through an arc. And this is the reason, or the principle, why when we turn the depth screws on the screed to change thickness, it doesn't just keep getting thicker and thicker and thicker all day long. It's because it travels through an arc, and then that screed reaches an equilibrium at a new thickness. And we'll show that in the slides coming up. So going back to angle of attack, normally 1/8 of an inch to 1/4 inch angle of attack, or that nose-up attitude. If we get too high of an angle of attack while we're paving, it's going to compact with the trailing edge of that screed. So very little of that screed plate will actually be riding on the mix. What tends to happen is you'll see a shiny looking mat. The rear of the screed plates will wear out faster. We'll have erratic screed behavior because we've only got a small contact area between the screed plate and the mix if that angle of attack is too high. If the angle's too low, it increases the shear factor and wear, and we're going to see an open mat texture. So angle of attack is very, very critical. To change thickness and slope, we change the angle of attack. We use the depth cranks, or sometimes called the screws, on the screed. So there's one on the left side, one on the right side, is one way to change thickness. Another way to change mat thickness is to use the toe point controls. So we can raise or lower our toe points using the buttons on the screed control panel at the back. So 2 ways of changing thickness. Most commonly, we're using the depth screws or cranks to change mat thickness. What happens when we change mat thickness, for example, we turn the depth cranks to increase mat thickness in this example. What happens is we increase the angle of attack of that screed. And when we do that, we allow more mix to flow underneath that screed, and that wants to raise that screed up to an increased mat thickness. If we turn the depth screws the other way, we would decrease the angle of attack, allow less mix underneath the screed, and the mat thickness would decrease. So we use our depth screws. What it does is temporarily changes that angle of attack. And then that screed, because it travels through that 360-degree arc that we talked about, will change the angle of attack, change mat thickness, and then it will resume that original angle of attack, that original 1/8 of an inch or 1/4 inch that we started out with. This slide just shows that going on. So on the left side, you can see paving along at our original angle of attack. Let's just say it was 1/4 of an inch. We changed our depth screws. Our mat got thicker as we paved along, and then it came back to equilibrium at that same 1/4 inch original angle of attack. How long does that take to happen? If we do it manually using the depth control screws, we're not using automatic grade control, it takes 5 toe arm lengths for that full thickness change to happen. So if I turn the depth cranks one time and take my hand off it, 5 toe arm lengths, basically 5 lengths of the paver before the full change takes place and it comes back to equilibrium at the new mat thickness. Other big thing that affects the paver operation is speed. So when we talk about factors affecting the screed, at a constant speed, the shear factor is constant, the depth remains constant. So if we increase speed, as we can see on the left side there, the shear factor actually decreases and our depth is going to decrease. So if we don't touch anything on the screed controls, we just speed up the paver, that screed's going to drop. Our mat thickness will decrease, it'll get thinner. If I slow the paver down without making any other changes, there's more resistance of the mix on the face of that screed. That screed, because it's free floating, wants to rise up. The mat thickness will increase. Our depth is going to increase. So paver speed in the real world, as you can see here, you get a line of trucks sitting in front of the paver. What's the tendency in the real world? You want to blow those trucks out. You want to get rid of them. The best thing to do here is don't panic. Stay with the established paving plan and get rid of those trucks in an orderly fashion. So maintain a constant paving speed. If we just blow and go and get rid of all those trucks at one time, then what happens? We stop, right? So we have to stop the paver, wait for more trucks to come back from the plant in another bunch. So the best thing, again, just get rid of the trucks in an orderly manner. Try to maintain a constant paving speed. That's the best thing we can do to maintain our smoothness and good density when we get to the compaction end of it. So again, speed really goes to the planning part of it. You can scratch numbers out by hand, take your total tonnage for the day, your paving width, your paving thickness, and calculate a paver speed that will get rid of the amount of mix that you are planning on delivering to the job that shift at a constant paving speed. So that's part of the planning process. It's one of the best things we can do is maintain a constant paving speed. Once we have that paving speed, the feeder system will be set, so that's our conveyors and augers to match our paving speed. If we do change paving speed during the day, right away as a paver operator, I need to think about changing my feed system. So my conveyors and augers. If I'm going to speed up or slow down, I want to change those accordingly to maintain the same head of material so that my screed doesn't drop or raise up when I change paver speed. So head of material, that's the mix in front of the face of the screed. Ideally, we want to have what we call half auger height, so we don't want to bury the augers in mix. We want to get a smooth, continuous movement of mix from the hopper back to the augers and across the face of the screed. Uniform force acting on the face of the screed there. So to control our head of material, we have either flow gates or ratio dials. All modern pavers, doesn't matter what brand or manufacturer they are, use some form of ratio dials. The older machines had flow gates in the tunnels where the conveyors come back that you raise or lower to control the amount of mix coming back to the screed. Auger speed, we can adjust the auger speed to control our head of material. And really important, the last one on the bullet list here is the position of our feed sensors. So that's our sonic feed sensors or our paddle feed sensors. where we position those to control that head of material. So again, half auger at the center of the screed is really where we want to hold that constant head of material. We want to see the top of the auger shaft or the auger flights. You don't want to bury them in mix. The auger does its best job when it can move that mix in a uniform manner from the center or from the conveyors out to the edges of the screed. If it's buried, you get segregation going on. Those augers become more of a boring machine than moving, as opposed to moving mix in a nice uniform manner. So changes in head of material are going to affect how that screed rides. So when that head of material drops, on the left side picture there, you can see a low head of material there. The resistance on the screed decreases, our depth of the mat or mat thickness is going to decrease. If our head of material, if we overload that screed and put too much mix back there, that's commonly happens when we use the manual overrides on the paver and jam a lot of mix back there all at once. There's a lot of resistance there on the screed. That screed, again, because it's free floating, wants to rise up or get thicker. So changes in head of material will affect our mat thickness and how that screed rides. So if we don't have a constant head of material, good control on it, our screed's going to be constantly rising and dropping as we pave along. We may not notice it that much looking at the mat, but after we compact it, run our smoothness IRI on it, those things will show up. So controlling head of material with the ratio dials on the bottom there or the flow gates on the top, again, that's just controlling the amount of mix that comes back to the center of the screed. So if the ratio dials are set too high or the flow gates are set too high, we get too much mix back there, our depth is most likely going to increase. If we don't get enough mix back there, flow gates are too low, choking it down, not letting enough mix back there, or the ratio dials are too low, the screed wants to drop. Another way we control head of material is with our auger height. So ideally, we want to have the bottom of that auger flight about 2 inches above the mat thickness or above the screed plate, so the top of our mat as we're paving along. If those augers are really high, we're going to carry a big head of material there. It's going to be a lot of mix on the face of that screed, and that screed's always going to have a tendency to want to rise up. And what happens in the field is we try to counteract that by using our depth control screws, or if we're in automatic grade control, the automatic grade controls are constantly trying to bring that screed back down, if you will. So auger height's really important for maintaining and controlling that head of material. This little video shows, ideally, we want that auger speed to be about 30 RPMs. So we look for a range of 20 to 40 RPM. That's about 2 seconds per revolution. So if I look at a bolt on the end of that auger shaft as it's turning and just count 1 1,000, 2 1,000, that's right there, 30 RPMs. Right in the middle of that 20 to 40 range. So a quick look, quick count to maintain or check our auger speed. Again, very important. Too high of an auger speed causes segregation. Too low of an auger speed, it's going to kind of drag the mix and we'll leave stripes in the mat. So here's what we're trying to avoid. So in this picture you can see an excessive head of material. Why do we have so much material in this picture? The main reason is this setup does not have the proper amount of auger extension that they should have going from the screed all the way out to the end gate. So in this picture again, a front mount screed, that auger should be within about 18 inches of the end gate or the paving width there. So they really need more auger extension and mainframe or tunnels in front of that auger. Otherwise, we're going to end up with a lot of segregation as well as that big head of material that's going to want to cause our screed to rise and fall. So there's a picture showing auger extensions, a proper setup for wide width paving. As far as feed sensors for controlling head of material, in this picture and circled you can see the sonic feed sensor pictured here. That's sending a sound wave measuring the distance from the feed sensor to the mix. So we can adjust that feed sensor on the Screed control panel to control the amount of mix that we have back there. Ideally, we want that sensor about 18 inches from the end of the auger shaft and also 18 inches from the mix that we're taking a reading off of. So just to review some of that, again, we've got the tractor and the Screed. The Screed is free floating. Proper head of material is half auger height at the center of the auger chamber. Depth cranks or toe points are used to change mat thickness and slope. So if we change our mat thickness manually using the depth cranks or the toe points, it takes 5 toe arm lengths for that full change to take place when we're paving manually. Changes in paving speed usually require a change to our feed system. Again, what we're trying to do there, if we change paving speed, is maintain that constant head of material. So we either have to increase or decrease the amount of mix coming back to keep the head of material constant. Increased head of material is going to cause that Screed to rise up. Decreased head of material will cause that Screed to drop or decrease in thickness. Continuous mix feed and paver speed will give us our best quality. So with that basis in mind, as far as the tractor, the Screed, what affects the Screed, head of material, what I'd like to cover now are 15 steps to just setting up the paver before we take off. So we've all gone down the road and you feel those little bumps in the road. I call them wee daddies because the kid's in the back seat, and we hit the bump and they go, wee daddy, and they love those, right? They want me to back up and go over it one more time because they like that ride. It's kind of like the roller coaster. I don't like them because I'm a paving guy and I think it should just be nice and smooth, and we shouldn't even know where we finished off yesterday and started again today. That's really what these 15 steps are focused on, to get a consistent takeoff every single time. So the goal, again, a smooth transverse joint, no mat defects right from the start. The straight edge really tells the truth here, right? So after we do construct and compact our transverse joint, we put a straight edge on it. We want to get that nice smooth transition between yesterday's paving and today's startup. The goal is really to minimize or even eliminate handwork. So we want to set the paver down, take off without handwork. Looking at this picture, is this a good place to start? I don't think so, right? We've got a rounded face there. So this is a mill and fill job. So they've dropped the rotor down on the mill or the grinder to start out here. We've got a rounded edge. Two things going on. That rounded edge, we won't get good mix in there to get compaction right at the edge. And the plunge cut, again, where they drop the rotor or the grinder drum in to start milling, is deeper than a few feet down the road once they got going. So what's going to happen? That thick area where they dropped it in right at the beginning there will compact more, and we'll have a dip there. So here's really a good starting point. We want a nice straight edge for a transverse joint. There's a few ways we can do it. One is to saw cut it, get rid of a little bit of the material from at the edge there, that rounded area, so we get a nice square edge. Clean it, put some tack coat on it, and then set the paver down and take off. There's other ways of doing this. Some crews at the end of the day, they'll put a board or a 2x4 or something square down there and then pave beyond it, pave a taper for traffic. When they come back the next day, they'll pull that 2x4 up, get rid of that little bit of waste material, the taper, and they'll have a nice square edge there that they can tack coat and then start paving. So the 15 steps to get that consistent takeoff. The first step we're going to do is heat the Screed up. The obvious reason there is so the mix will not stick to the Screed. We've got hot mix. If we had a cold Screed, as you can see in this picture, once they take off, the mix wants that cold Screed and hot mix want to stick to each other and drag, and it's going to leave a terrible mat. There's going to be a lot of segregation, handwork to do. So heat the Screed up. We do that while the Screed is off the ground, up in the air, maybe 6-8 inches off the ground, to minimize the Screed from cooling off due to wind and other things. So Screed's in the air, we turn the Screed heat on. Step 2, position our toe point cylinders. So again, the big thing with paving, once we take off, when we get ready to take off, we want to have what we call a straight line of pull between the toe point up at the front of the paver there. That's where the screed is connected to the tractor. So that's a pin, it's a pivot point. It can rotate around there. Remember the 360-degree pivot point there? And then back at the screed is another pin. So that's where the two ends where that toe arm's connected. We want a straight line of pull. If I'm pulling up like this when we take off, I'm going to have a bump in the mat. If I'm pulling down, toe points are too low, I'm going to have a dip in the mat. So set our toe points. We're going to set those not necessarily at 0 on the scale, on the toe point scale, where we'll actually have to figure it out because it's a little different for every paver. The first time I get out there, I'll actually just measure the height with a tape from the ground to the toe point. I'll do the same back at the screed to the pivot point, and I know that I've got a straight line of pull to take off when I get ready to actually take off. This picture, or this slide here, is just showing an example. So a 2.5-inch mat is what we want to put down. Again, toe point scales are different on every paver, every model or make of paver, so you need to figure out where that straight line of pull is on your machine. But the goal here, again, setting those toe points to establish that straight line of pull. So all these steps 1 to 15 as I go through them are done, steps 1 to 6 are done with the screed up in the air off the ground. So just keep that in mind as we're going through here. So step 3, screed still off the ground. Now we're going to set our paving width. So on our hydraulic extendable screed, for example, if we had a 10-foot wide main screed and I want to pave 13 feet wide, ideally I want to put 1.5 foot extension on the left side, 1.5 foot on the right side, and do equal extension on both sides, ideally. Sometimes we can't do that because we have a shoulder break or different things, so I may have all the extension on one side to achieve my paving width. But whenever possible, equal paving width or extension on both sides. Step 4, set the main screed crown. So in the center of the main screed, there is an adjustment there. You can have what we call negative crown. So that's more like a V or a swale type thing. Or we can have positive crown, which is what, if we do have crown in the screed, most times it's positive crown. So it may be 1 or 2%. And then again, that's for drainage from the center of the roadway, depending on what we're paving that day. A lot of times we're just paving flat, so we have 0 crown in the center of that screed. So we may have a 12-foot lane, driving lane. We're not going to have crown in the center of that driving lane, so in that example, we would just have 0 crown or flat. Step 5, we'll set our extender height here. And again, this is really important on the extender height because what this is actually doing is setting our angle of attack that we talked about. So that 1/4 inch angle of attack that I talked about earlier, this is where we're establishing that. So if I set on a rear mount screed, for example, 1/4 inch above 0, my extender height, when I get to the steps where I'm going to set the screed on the ground, that main screed will rock back to 1/4 inch. That'll be my angle of attack. If I set these extenders right now, just say something crazy, say I set it at 1 inch, when I get to step 7 and set my screed on the ground, the main screed's going to rock back to 1 inch angle of attack. That's going to end up riding on its tail. It's going to behave erratic and all that. So again, angle of attack, really important. This is where we're actually establishing that angle of attack is in step 5, setting our extender height. This slide here just shows you another schematic or picture of how the main screed and the extender, once we do set it down, that main screed will rock back to that same angle of attack or extender height that we set our extenders at. So again, extender height, very critical because it really is establishing the angle of attack that we'll be paving at. Step 6, we set our extender slope. So if we do have any slope in our extensions, this is when we set that. Again, remember the screed is still up in the air off the ground. Sometimes I see crews trying to change all these things while the screed's resting on the ground. We have kind of two problems with that. One is it's very hard on the equipment, and more importantly, I guess, in terms of quality, is it's putting forces and tension on that screed. Remember that screed's free floating? It does its best job when it's no stress is acting on it, just floating on top of that mix. If we try making these types of adjustments while the screed's on the ground, again, we can put twist, torsion, tension on that screed, and then once we take off and we're on that loose mix that can move, that screed might torque into a different shape than we want it to. So again, all these are done off the ground. Step 7, we're going to find some starter boards to set the screed on to take off. We can either do that, sometimes depending on the job, the crew may actually build a pad with mix to take off from. Most often we see starter boards. It's a good idea to have different thickness starter boards on your paver or on the truck, on the job site. What we want to make sure with these starter boards when we're taking off from a transverse joint or just a new mat is that we also factor in thickness for compaction. So typically asphalt mix will compact a 1/4 inch for every 1 inch of thickness. So for example, if we want a final 2-inch thick mat after compaction, we'll put down 2.5 inches of loose mix. So we need to think about that when we choose our board thickness to take off with. And that's what this guy's doing here in this picture. He's measuring the mat thickness. He's going to add a 1/4 inch per inch for his starter board thickness. This picture just shows another way of doing it. The crew's building a pad in this parking lot to set the screed on to take off from. So the same idea, only building a pad with mix. There's your starter boards. The big thing here is those boards need to be long enough to go all the way underneath both the main screed plate thickness and the extenders. Typically, they vary a little bit based on the manufacturer, but at a minimum, those boards need to be 3 feet long, some cases even 4 feet, depending on the screed. So always recommended boards at least 3 feet long, 4 feet's even better to support the main screed and the extenders. If they're not big enough, throw a pop can under there or a big rock or something. Once that screed takes off, it's just going to rock or roll over and nose down. So we need boards to support the full length of that screed. And again, this picture is showing the board underneath, a little hard, difficult to see there, but 3 to 4 feet long to support both under the main screed and the extenders. And at this time, we also want to raise our end gates up. We don't want the end gates digging into the grade, but we do want them on the joint if we are joint matching. Step 7, we lower the screed. So we do that by putting it in what we call float mode. So you've got buttons on the tractor, on the paver to raise and lower the screed. But when we put it into float, what that does is lowers the screed and releases all the tension or any forces acting on that screed from the hydraulic cylinders that raise and lower it. So we put it in float mode, let the screed come down onto the starting boards. And then on the right-hand picture there, this is very key, is we want to take out the slack. So you'll see where the arrow is pointing in that right-hand picture. That's the pin, or the toe point, that pulls the screed there. There's about 1.5 inch or 2 inch slot there. And we want to inch that paver forward and take out the slack so that pin is tight up against the face of that slotted connection. That way when we take off, we won't get any jerky motion or anything like that when we take off. The reason that slot is there is the idea is that it will help a little bit if we get a crazy truck driver that backs up and bumps into the paver. There's just a little bit of movement there before that screed will dig into the mat. So lower the screed, take out the slack. Now we want to null the screed out. What nulling does, once we set it down, take out the slack, there's going to be a bit of tension on there again. We want to null it out, take all the tension, all the forces off of that screed. So we'll turn the depth screws. We do one side at a time. So pick your side, do the left first or the right side first. Turn that depth crank until it's loose. You don't feel any tension on it. Now go to the other side and do the same thing. One mistake I see a lot of crews do is you'll see someone on the left side, someone on the right side, both turning those depth cranks at the same time to null out. When that happens, you're kind of rolling the dice. You might get it right, or you might get what we call a false null. So it'll feel loose to both guys on the right and left side, but it's not actually nulled out. They just happen to kind of both hit a sweet spot at the same time where it felt loose, but there's still tension on the screed. So do one side, get it loose, do the other side, and then our screed's nulled out. Before we come to positioning our end gates, right after we null, we want to turn the depth crank just to tension. Don't put any cranks into it just until we start to feel tension. Lock those depth screws. Step 9, position our end gates. We're going to lower it down to contact the grade. So whether we're paving a new mat or unconfined edge, or whether we're joint matching, we want to lower that end gate. We want to see about 1 inch in that spring. And those springs typically, I think all manufacturers are the same or very close, about 4 inches of play in that spring. So we turn those end gates down till we got about 1 inch. And what that will do is allow the end gate to follow the grade and give us a nice square edge or square longitudinal joint. And that's important when it comes to joint densities and joint compaction. And that's what this slide's showing here. So on step 9, why are the end gates important? A nice square edge will get a lot better joint density when we come back and match that lane and compact it. So we'll talk about that more later in another presentation on joint compaction. Step 10, set our auger height. So auger height will affect, as we mentioned earlier, the head of material that we're carrying. It's also going to have a big effect on our mat texture. So what our mat looks like, if it's an open textured mat, if it looks nice and tight. So where we want to start with that auger height is the bottom of the auger flights about 2 inches above the level of the mat that we're paving. So if you look at the picture shown here, the very bottom of that auger is 2 inches above the thickness of the mat that's coming out behind the screed there. So most augers on the paver are 16-inch diameter, so that makes it 8 inches from the center of the shaft to the bottom of the auger flight. So that's 8 inches, and then I want to be 2 inches above, so 8 plus 2 is 10. So when I set this up, I just get my tape out and measure 10 inches plus whatever my mat thickness is. Let's just say it's 2.5 inches loose. So I'll measure 12.5 inches from the grade to the center of the auger shaft. I don't do this every time. I'll measure it for some common mat thicknesses that I use, maybe 2 inches, 3, 4. And there's a scale on the back of the tractor for auger height. And I can just get up there with a Sharpie or a marker and just mark off 2 inches, 3 inches. So you don't have to get your tape out every single time and measure auger height. Step 11, position the feed sensors. So whether I'm using mechanical or paddle sensors or sonic feed sensors that use sound waves, I want to aim those properly in step 11. Why don't I do this before? Because I want to get everything else set up first. If I set these ahead of time, they just won't be aimed properly because I don't have my screed nulled out and auger height and all that stuff. So again, if it's a paddle sensor, I want it about 18 inches from the end of the auger flight. If it's a sonic sensor, I want to kind of estimate where that beam is aiming. A lot of times I'll get a tape measure out and just kind of hold it on the sensor so I can see where that sound wave or sound beam is pointing. And I want that about 18 inches from the end of the auger flight as well. So it doesn't matter, mechanical or sonic. Aim it 18 inches from the end of the auger shaft. And this slide shows a sonic feed sensor position. So it's 18 inches from the end of the auger shaft, and it's also aimed as much as possible perpendicular or 90 degrees to the mix. So we kind of have to imagine or picture the way the mix is going to flow back off the end of the auger to the end gate and position our feed sensor or aim it towards it. So again, as much as we can at 90 degrees for a sonic feed sensor. That's sound waves, so if we don't aim it as square as possible, it loses some signal. We just don't get as good a control over the mix height with the sonic sensor if it's not aimed as at 90 degrees to the mix. The working range for sonic sensors, typically 12 to 32 inches is the working range. So we're aiming it where we're positioned about 18 inches away, so it gives us lots of flexibility. Step 12, set the feeder controls. So this picture is just showing a paver with a digital control to change your feed controls. So that's your conveyors and your augers. So whether you have this type of control panel or dials, set the conveyors at 40% and set our mix height dial at 60%. Typically the mix height dial is down on the Screed control panels. It is there on all pavers. Some pavers also have it up top at the operator station. Conveyors, usually always able to set those at the operator station. Some models of pavers you can also set the conveyors down at the Screed control panel. So conveyors at 40, mix height at 60. Why does this work, or why is it a good place to start? Again, it's just going back to consistency. We've aimed our feed sensors using our 18-inch rules, our 90-degree rule. We've nulled everything out. We've set everything up in a very specific way so far. So setting these at 40 and 60 is just, again, adding more consistency, and it works 99% of the time at those settings. Step 13, finally, we're going to get some mix in here. Fill the auger chamber to half auger height. Remember, that's our ideal head of material, right? Half auger height. So we're going to fill this Screed chamber, auger chamber up right now the same way we want to be after we're 100 feet down the road, half a mile down the road. So this is our head of material. So fill it up to half auger height. We want to have the best control over doing that. We want to do it with the machine or the paver in low idle. So one mistake I see crews make is the paver operator wants to be nice and friendly to the guys down on the ground. So he'll manually feed that at high idle and literally overload that Screed to start with. It's nice because people don't have to shovel or do any handwork down on the ground to fill up that auger chamber. But the problem with that is it's usually too much head of material there. So when we take off, we'll end up with a little bump. And those conveyors, remember, they run underneath in a loop from the hopper back to the augers, underneath the hopper and back again. So if we have that paver on high idle and full manual override to fill the auger chamber, it drags mix back underneath the tractor. So when we take off again, we got a big pile head of material, and we've also got mix under the tractor. All that's going to cause a big bump at our joint. So we manually alternate, convey a little mix back, auger it out, convey some more mix back from the hopper, auger it out, and we do that on the left side and the right side, being very careful not to overfill the auger chamber. Step 14, now is when we set our automatic grade and slope controls. So whether we're paving manually or using automatics, which is covered in another training segment, if we're using automatic grade and slope control, now is the time that we would set that up, just before we get ready to take off. Personally, I like to take off in automatic, so I'll get set up, bench or zero out my automatic grade controls before I even take off. Other crews like to take off manually and then engage the automatic controls. So there's two ways of doing it, but step 14 is when we set that up. And just real quick on automatic grade control, we've got a grade sensor shown here. This is a sonic sensor. There's also contact sensors, but sensor position is really important. So when we do set up our automatic grade control, if I want a joint match, I'll line that sensor up with the auger shaft at the back. I'll get a perfect joint match with the adjacent lane that I'm paving against. Or if I'm paving for thickness and following the existing grade, this will follow it exactly. A lot of times I don't want to do that because I want a smoother mat than what I'm paving over top of, right? So it depends what I'm doing as to where I put this sensor. I want a smooth mat, and it's just a single sensor. I put it up by the toe point. The Screed's going to react a lot slower, but it's going to give me a nicer, smoother mat. Step 15, right, getting ready to take off. So let's go through our checks. Make sure the feed system is in automatic. So that's my sonic feed sensors. If I don't switch those into auto before I take off, I'm going to get started and there won't be any mix coming back. Make sure I'm in pave mode with the paver, not in travel mode or maneuver mode. So make sure I'm in pave mode. Make sure again that the Screed is still in the float position. Throttle up, so get my RPMs up there for engine speed that I'll operate at. Set my paver speed. So on some of the new pavers, you can actually set your feet per minute before you even take off. Most machines that we're still using today, you don't know what your paving speed is until you propel forward and actually watch it on the speedometer. So, or using the speed dial to get up to your feet per minute. Release the brake, move the propel lever full forward. So on a machine where I can set my paving speed before I take off, I'm just going to move the propel lever full forward and get up to my 35 feet per minute, for example. I want to get to speed quickly and smoothly to maintain the best head of material and avoid having a bump or a dip in the mat. If I've got a speed dial, I'll do the same thing, but I'll start at 0 with the speed dial, put the propel lever full forward, turn the speed dial from 0 up to my 35 feet per minute, or whatever my paving speed is, target speed. And then from that point on, whenever I have to stop the paver, I'll just use the propel lever. I won't touch the speed dial. That way I know when I propel full forward, I'm just going to go right up to 35 feet a minute quickly and smoothly. So I'm all ready to do that. I'm going to pull off the starting boards, quickly get up to speed. As soon as that happens, I'm going to check my mix feed. Number one, I want to make sure as a paver operator and on the Screed that I've got mix coming back to the Screed. None of the adjustments make any good if there's no mix there. So check the feed system is working. Then I'm going to check my auger speed. So I want to make sure I'm in that 20 to 40 RPM range. That's what, 2 seconds per revolution? That's 30 RPM, right in the middle of the range there. So I got mix, I got auger speed, now I'm going to check for lines in the mat. So again, as paving begins, Screed person, make sure I got mix coming back. I'm going to adjust my mix height dial if I need to make sure I've got that half auger height head of material. Operator is going to look down into the Screed area, the auger chamber, and adjust the conveyor ratio dials if necessary to get that half auger height head of material there. So the operator also really is controlling auger speed, because when I change the amount of mix coming back, remember the sonic feed sensors are constantly sending a signal to maintain that head of material. So if I bring more mix back, those augers will slow down. If I bring less mix back, turn my conveyors down, then less mix comes back. Those augers will speed up to satisfy the feed sensors. So paver operator really controls auger speed. So that's what the paver operator is going to look at, half auger height and 20 to 40 RPM. If you're not in the right range for if the augers are on and off, and this is one of the most common things that I see are augers turn, stop, that is almost always result of the feed sensors just aren't aimed properly. So just tweak them. You can do it as you're moving. Loosen the wing nut there, re-aim that sonic feed sensor so that it's hitting the live moving material. You don't want to be aimed down straight at the grade or catch the edge of where that mix is rolling off the augers and that sort of thing. You want to catch a good area to keep constant auger movement. So you got the mixed feed, everything's dialed in, half auger height, 20 to 40 RPM. Now you're going to look back, check your mat texture. Again, it should be uniform from one edge to the other if everything is set up properly and working properly. The most common things that you might see, and I'll just show a couple slides on those, is what we call transition marks. So in this picture, you can see two lines coming out behind the screed. What I do in the field is I can't remember extension height up, down, and all that. So I just follow that line up to the screed and see where it's coming from. So in this picture, if I follow that line, it's inside the main screed. It's actually on the inside edge of those extenders. So what that tells me is my extender heights aren't matching with the main screed. So in this case, I need to raise my extender up just a little bit to get rid of that line. And you just hold the raise extender button until the line goes away, and then take your finger off the button, and you're done. The opposite, again, we got lines in the mat there, longitudinal lines that are, they're just staying there, they're not going away. I follow that line, it's in line with the main screed. What that's telling me is my extender is higher than my main screed. So I just need to hold the lower extender button on the right side, do the same on the left side if you have the line on both sides, until that line disappears, and then take your finger off the button. And that's all you need to do to get rid of those lines. And that's the most common thing that I see in the field. And sometimes I'll see crews go all day long with that. But just a real quick fix, only takes a few seconds. Once you got all that done, just kick back and relax, right? Keep our paving speed constant, so just remember speed changes cause bumps and dips in the mat because head of material changes. So if we change speed, paver operator, first thing I need to think about as I grab that propel lever or speed dial to change speed is I should probably be changing my feed system, meaning conveyors as well. And that's it. So that's paver operations, basics, introduction of the tractor, the screed, how they work, and 15 steps to getting a consistent takeoff every time. Thank you.